Today we are looking at trig functions of real numbers, and we're going to be looking at what we call periodic functions. And the good thing about this section is you have your unit circle because you're going to need this. And your circle should be filled out. Of course, as you see, mine is blank. But what I wanted to show you all, or remind you, is the x-coordinates are always cosine of theta. The y-coordinates are always sine of theta. And to find tangent of theta, remember we do y over x, or sine over cosine. So around your circle, those coordinates, make sure those are filled out correctly because they're going to ask you for the exact value of different sine or different trig functions. So if you already have these filled out, it's going to make everything much easier. And so, for example, they may ask you for sine pi of 3. Well, we know pi over 3 is right here. And then your coordinates should already be filled out. This is 1/2, and my y-coordinate is square root of 3 over 2. So if they ask you for sine of pi over 3, then that answer would be radical 3 over 2. So this is kind of like a review for us. And then, sometimes it's going to be undefined depending upon if they ask you for any of the quadrant angles, because that's the only time when you can have an undefined trig function. So that's what we're going to be doing. They're going to give you a different function and ask you to find the trig value. If they ask you to find all trig values, for example, if they wanted all 6 of those, if you have sine, you know that you have cosecant, because it's the reciprocal, but you have to make sure you rationalize it. If you have cosine, then you know you have secant, which is a reciprocal. And then, of course, tangent. Most of you all filled out the tangent, which in this case will be square root of 3. I'll just put it over here. Which will mean cotangent would be the reciprocal but rationalized. And those will be all the trig functions of that angle or t. Because sometimes they call the angle t. So if you have the coordinate and they ask you and they tell you that P is a point on the unit circle corresponding to a real number, then you'll have all your values, or you can find all the 6 trig functions. Or if they ask for a specific one, you'll do that specific one. Okay, now we're going to talk about even and odd trig functions. When you think about the unit circle, and let me just draw this. And if we go counterclockwise, our angle, which is we're calling it angle T, is positive. But if we go clockwise, now T is negative. When they refer to even and odd functions, well, first of all, only cosine and secant are even. So I'll write that. So cosine and secant are even. And that's because when you go around a circle, we'll use pi over 6, for example. Or let's use pi over 4. If you notice, the value, square root of 2 over 2, the exact value of cosine of 45 degrees. And in here, this would be negative pi over 4. See this? If you notice, cosine of pi over 4 and cosine of negative pi over 4 are exactly the same. That's why we call those even functions. You know, if you do the reciprocal, the same thing's going to happen. So cosine of a negative angle and cosine of a positive angle are exactly the same. Same with secant. Okay? However, if you look at, and these are odd functions, let's first look at sine. If you look at sine of 45 degrees, it's positive. But if you go in a negative direction, it's negative. So that's why we say that sine is an odd function. And then, of course, if sine is odd, that means cosecant is odd. Because if you do the reciprocal, the same thing happens. And then if we have to find tangent by doing y over x, well, if you go the negative way and you do y over x, it's going to be negative. So tangent is also odd because the signs are opposite, which means it's reciprocal. It's going to have the same effect. So that's what they mean by even and odd functions. So let's look at an example. So an example of this would be if they ask you to find cosine of pi over 6, and then if they wanted you to go back and find cosine of negative pi over 6. Well, we know that cosine of pi over 6 is, and use your unit circle to help you, square root of 3 over 2. Well, because cosine is an even function, even if we go clockwise, it'll be exactly the same. So that's what they mean. And then, or if they do something like tangent 5 pi over 3 and tangent of negative 5 pi over 3. Well, using your unit circle, tangent of 5 pi over 3 is negative square root of 3. But if you go in the opposite direction, it's going to be positive square root of 3. And so that's what that means. And then the last part is a review. So if they ask for something like sine of 3 pi over 4, which is on our unit circle. And if you use your unit circle, that would be the square root of 2 over 2. But then if they go back and ask you for sine of 11 pi over 4, which is not, Remember, you have to add or subtract 2 pi, because it's in radians, until you get a angle that is on our unit circle. So, and sometimes remember you have to do it more than once. So I'm going to subtract 2 pi, but I have to get a common denominator, which will make that 8 pi over 4. And look, we're back to 3 pi over 4. And we call those, remember, coterminal angles because they end at the same point. So since we already got that answer in part A, it'll be the exact same thing. So those are examples of finding trig functions of the exact same value. And then if they ask you something like cotangent of pi over 2, and then cotangent of 15 pi over 2. Now, some students like to count around the circle, and that's fine because you can get there as well. Cotangent, remember, is x over y, which is 0, because it's okay to have 0 in the numerator. Now, 15 pi over 2, of course, is not on our circle. As a matter of fact, you would have to go around a circle a couple of times until you get something that is. Because going one time around would be 4 pi over 2. And you know that's still not enough. So we have to do 4, 8, 12. 12 would be what we probably should use. So 15 pi over 2 minus 12 pi over 2, which will give us 3 pi over 2, which is on our unit circle. So basically we're looking for and if you notice 3 pi over 2 and pi over 2 don't land in the same spot. So that means you would have to subtract one more time. Two pi. And you're going to have to subtract pi this time because it's closer. And that'll give you pi over 2, which is the same thing we got in part A. So since we have that answer is 0. So this is just showing how we can get coterminal angles. And remember, you can count around the circle, or you can do adding or subtracting like I did. And make sure you have this circle when you're doing your assignment because it makes everything much easier.